What happens if you just let an AI agent run completely wild for an entire week? And, what's physically stopping us from doing that at massive scale right now? Welcome to The Explainer. Today, we're ripping a strategic playbook straight from a masterclass by Jeff Dean, the co-inventor of systems like TensorFlow and the TPU. We're stripping away the hype to show you how these underlying systems actually work and how you can leverage them to your advantage. We're breaking this down systematically today. We'll cover the next AI milestones, hidden hardware bottlenecks, mastering context engineering, where startups can actually win, and finally, the ultimate founder skill. Let's get right into it. All right, Section 1, the next AI milestones. We're moving from junior engineers to fully autonomous agents. Seriously, I want you to pause and think about this for a second. What actually happens when an AI agent runs for a whole week? We're so conditioned for instant gratification, right? You type a prompt, you get a response in 3 seconds flat. But Jeff Dean points out that we are undergoing a massive paradigm shift toward complex software engineering asks that take serious, uninterrupted time. Dean puts it perfectly. He says, AI is at the level of a junior engineer. You can get them to run for days or weeks and do really, really complicated tasks. That is exactly where we are today. The real milestone isn't just a slightly wittier chatbot. It's the ability to tell an agent, hey, go independently rewrite this entire codebase in a different language, and then letting it cook for weeks. Which brings us to Section 2, the hidden hardware bottlenecks, or really the physics of AI. So when founders talk about model problems, half the time they're actually talking about energy problems. Listen to this napkin math. Moving data around literally takes 1,000 times more energy than just computing it once it's already there. 1,000 times. Let's define what's going on here. Data I/O, moving data in and out of a processor, is this massive, unavoidable energy and speed bottleneck. It literally dictates how we have to build AI systems. So, you know how we batch data together when training models? That's not just some clever software trick. It is a forced physical workaround because we absolutely have to avoid paying that massive 1,000x energy penalty every single time we move a piece of information. And because of this insane data movement crisis, we needed specialized hardware. Enter the TPU, the Tensor Processing Unit, that Dean actually helped invent at Google. By hyper-optimizing just for low-precision linear algebra, TPUs hit 30 to 80 times better energy efficiency and 20 to 30 times lower latency compared to baseline CPUs. The takeaway? Once you solve the underlying physics problem, the software can finally flourish. All right, up next, Section 3, mastering context engineering and building the system around the model. Think about the sheer difference here. Training a model, that's like stirring trillions of tokens into this chaotic, opaque soup of parameters. But context engineering, that's about surrounding the model with clear, specific tools, APIs, and targeted retrieval history. It's just far more accessible and precise for everyday builders. Instead of trying to alter the AI's fundamental brain, you're explicitly guiding its environment with clear rules. And mastering that context engineering unlocks something Dean predicts is going to absolutely explode by 2027, the automated AI scientific method. It's a simple loop: propose an experiment, implement it, evaluate the results, and iterate. Very soon, AI systems are going to use this exact tightly automated loop to rapidly self-improve. They'll break massive, impossible problems down into tiny subproblems and just knock them out sequentially. To really grasp the scale of automating this loop, just look at quantum chemistry. By swapping out a slow, traditional chemistry simulator in that evaluate step and replacing it with a trained neural network, they sped up the validation process by 300,000 times. 300,000! A computing endeavor that used to take 6 agonizing months? Yeah, that finishes during your lunch break now. Moving on to Section 4, where startups can win, or what I call the 1% rule. This is pure actionable strategy right here. How does a tiny startup realistically compete against tech giants hoarding all the compute? Simple strategy. Avoid any area where general frontier models currently succeed about 20% of the time. Look, if they can do it 20% of the time today, they'll do it 90% of the time next year. You have to build in the extreme edge cases where those models have a 0 to 1% success rate. That is exactly where your moat lives. That tiny 1% zone, that's your niche advantage. Startups win by focusing relentlessly on organizing highly personal, proprietary data that general models simply do not have the legal or structural access to. Or they win by building hyper-specialized models. Think about how AlphaFold was built exclusively for protein folding. Basically, you have to focus where the giants just aren't looking. Which brings us to our final section, the ultimate founder skill, developing taste. This addresses the elephant in the room. What's actually left for humans to do when AI is writing all the code? The answer is developing taste. It's that vital human ability to specify clear objectives and actually pick the right problems to solve in the first place. How do you build it? Dean says you need diverse problem-solving experience, you need to actively write down 12-month predictions and track them to calibrate your intuition, and you need to run crazy thought experiments. Like, what if we built systems assuming chips had 20 errors a day instead of 0? Questioning those fundamental assumptions is exactly how you build taste. And hey, if you ever doubt the value of the human mind in this new era, think about this. By the time a human turns 18, they've consumed roughly 1,000 times less data than a frontier AI model. 1,000 times less! Yet that human can perform on par, learn continuously, and apply wild intuition across totally different domains. Our intuition and our taste remain incredibly scarce, powerful assets. Unlikely to have significant impact. That was literally a reviewer rejecting Jeff Dean's foundational 2014 paper on model distillation, a technique that is now used by pretty much everyone in the industry to make models smaller, faster, and cheaper. Having true taste often means trusting your own vision, even when the so-called experts are telling you you're dead wrong. So when AI agents can write all the code, what impossible problem will your taste lead you to solve? Let's do a hardcore recap of what we covered today. AI is currently acting as a junior engineer, data I/O hits you with a 1000x energy penalty, TPUs boost efficiency up to 80x, and your startup moat lives exclusively in the 1% success zone. If you take away just one thing today, make it this. Don't compete on general compute. Compete on context engineering and hyper-niche data. Now, time for a hardcore debate. Based on Dean's playbook, do you think relying on context engineering is a genius long-term design or a massive pitfall once frontier models scale even larger? Drop your argument in the comments. And hey, if you leave a comment right now, we'll send you our complete mind map of Jeff Dean's AI predictions. Thanks for joining this explainer, and we'll catch you next time.